Good afternoon, children. Today is the surface areas and volumes. In this session, I'm going to explain the surface areas and volumes of spheres and hemisphere. In the previous class, we studied about the cube, cuboid, cone, and cylinder. So, cube, cuboid, cylinder, and cone, its lateral surface area or curved surface area and total surface areas of all the four solid shapes. Now, today is I'm explaining about the sphere. You know that the sphere. So, sphere is nothing but a ball shape, a globe. All these are the examples. See, a ball or a globe, everything which is a round in shape, even a round marble, that is also a sphere. Your shot put is also a sphere. Okay, a laddu, it is in the form of a sphere. Now, how to find the surface area and volume of this sphere and hemisphere? So, hemisphere is nothing but the half of a sphere. Hemisphere is a half of a sphere. Okay, now we are learned that the cylinder, when a rectangular sheet is rolled along its any one side, we will get a cylinder, right? In the same way, a right angle triangle, if you are rotate on any one of its right angle side, you will get a cone. In the same way, a circle, you have a circle. Okay, cut it by drawing a diameter. When you draw the diameter, it divides the circle into two parts. Divides the circle into two parts. Here is this is called semicircle. This is a semicircle. Now, what you can do is take a stick, then paste that stick along this diameter and do like this, rotate. So when you do that, you will get a sphere shape. That means imagine that you will get a globe shape structure. That is a sphere. Okay, a hemicircle means semicircle is rotated on its diameter. We will get a sphere. A sphere. Clear? Now, how to find the surface area? Here, for this, the sphere whole thing is a total surface area. There is no curved surface area for this. Separate a curved surface area, but this has a curved surface area. Now, how to find the surface area of a sphere? Okay, so for this, how to find out that the surface area? The simple one. What you can do is you have a plastic ball. Imagine that this is a plastic ball which is a round shape. Now at the center you have a mark. Along that you cut the ball. Okay, when you cut the ball, you will get a bowl structure like this. Two bowls you are getting like this. When you cut a ball, you will get two bowl structures. Okay, see, these two bowl structures are called as hemispheres. These are called as hemispheres. These two are called hemisphere. Now, we know that the area of circle. Area of circle. So what is the area of circle? In the previous one, cylinder and cone, you have studied that area of circle is given by pi r square. Area of circle is given by pi r square. Now, take one bowl structure. Then you have one circular base. Now, hold that bowl on a thermocol sheet. Then trace the mark. Trace the mark like this and cut that thermocol. That means it is in the circle shape. Then keep that on the bowl so that it will cover the whole circular part. Understood? Now, what you can do is at the center put a one pin, then take a thread, go on winding that thread along this. So like this. Without giving gap, you just wind the thread. Now, how much length is required to cover that thermocol circular region? Thermocol circular region, that is the length. Note on one side, length of the thread. Length of the thread. Okay. Now, next is what? Reverse the bowl like this. Put a pin here. Then again, keeping this initial point, go on, put the thread around this circular region. Without giving gap, you do like this. Like this. So here this is a what? You are covering the upper part of a bowl. Okay. Now remove that thread and then compare this length and this length. Compare the length of the thread used for covering this part and this part. You will notice that the length of this circular part is half of the length of this. It means or the length of thread required to cover this circular part is exactly double of this. Are you understood? Here the length of the thread used to cover this part is double the length of the thread required to complete the circular region. So from this you can conclude that the area of this part, this area is pi r square and this part is exactly 2 pi r square. So from this experiment, you can conclude that the area of the circular part, that means the upper part of the hemisphere, is exactly double the area of this circular region. Clear? So here also you have 2 pi r square. Here also 2 pi r square. So you find out the area of the two bowls, upper bowls, right? Then when you join this, So when you join this pi r square merge inside, then this is what? 2 pi r square, and here is one more 2 pi r square. So what this you will get? 4 pi r square. 4 pi r square, where r is the radius of the sphere. R is the radius of the sphere. Clear? This is what? The curved surface area. Curved means total surface area of a sphere. Okay. So TSA. TSA of sphere. TSA of sphere. TSA of sphere equals 4 pi r square. So look at that, how you got that 4 pi r square. 4 pi r square. Clear? So that is the area of what? The total surface area of a sphere. Clear? Now next I am continuing with the hemisphere. Now next is a hemisphere. So hemisphere, you know that it is a half part of a sphere. This is the hemisphere. Hemisphere, it has both curved surface area and total surface area. So here this part is called as curved surface area. This part is CSA. CSA, curved surface area of hemisphere. Hemisphere, curved surface area of hemisphere is equal to, you know, the curved surface, it is what? Only 2 pi r square. Curved surface area of a hemisphere is 2 pi r square. Now what is this? So total surface area. TSA of hemisphere. Total surface area of a hemisphere is this part plus this. So this is 2 pi r square and this is 1 pi r square. So when you add this is 2 pi r square plus 1 pi r square. Clear this? This 2 pi r square is this, the curved surface area. For that you are adding a 1 pi r square, the top one. So total is 3 pi r square. So this is a square unit. So this is very important. You should write the unit, square unit. So for all the areas you should write the square unit. Units you should write. So this is what the surface areas, curved surface area and total surface area of a sphere and hemisphere. So we are remembering this in terms of 1, 2, 3, 4. So what is that? 1, 2, 3, 4. So here is 1 pi r square. 1 pi r square is circle. 1 pi r square is circle. 2 pi r square is CSA of hemisphere. CSA of hemisphere. 3 pi r square is total surface area of hemisphere. And this 4 pi r square is the total surface area of a sphere. Clear? 1, 2, 3, 4. 1 pi r square, area of circle. 2 pi r square, curved surface area of hemisphere. 3 pi r square, total surface area of hemisphere. And 4 pi r square is the total surface area of a sphere. Clear? This is what? The surface areas of a sphere. Okay. Now, next is volume. So, how much are the capacity of a ball, a round shape solid object? Okay. So, here I am writing directly. There is no proof for that. You just write down this. Sphere is 4 by 3 pi r cube. 4 by 3 pi r cube is the volume of the sphere. Volume of a sphere is 4 by 3 pi r cube, and whereas the volume of hemisphere is half of that. Volume of hemisphere is equal to 2 by 3 pi r cube. So only in this we are getting a r cube, radius of the sphere, which is issued a cubit, right? So volume of sphere and volume of hemisphere. So if you have put this in the form of a table, here is sphere and hemisphere. This is curved surface area, total surface area, and volume. So here there is no curved surface area of sphere, only the total surface area 4 pi r square, and this is volume 4 by 3 pi r cube. 4 by 3 pi r cube. Hemisphere CSA is 2 pi r square. Total surface area is 3 pi r square, and this is 2 by 3 pi r cube. 2 by 3 pi r cube. This is what the formulas come across a sphere and hemisphere. Clear? Now we make use of these formulas and we will solve some problems. Understood? Just go through the videos again and again. Repeat the videos and write down once or twice. You should write all these things in your classwork. Okay. And one more thing, if you have any doubt, you call at any time and clarify your doubts. Okay. Now, I'm going to problem now. The surface areas of two hemispheres. The surface areas of two hemispheres. Two hemispheres are in the ratio 25 is to 49. Find the ratio of their radii. Find the ratio of their radii. This is the first problem. See here, the surface areas of two hemispheres are in the ratio 25 is to 49. So look at this. Here surface area is 25 and another one is 49. Now from this area itself we can conclude that here this is the smaller sphere and this is the bigger sphere. So let us take solution. Let R be the radius of smaller circle, smaller sphere, areas of smaller sphere. Let R be the radius of smaller sphere and capital R be the radius of bigger sphere. Or be the radius of bigger sphere. Then ratio is given that ratio of radii is given by R is to R. Now surface areas is 4 pi r square whole unit by 4 pi capital R square equals 25 by 49. Now 4 get cancelled, pi get cancelled. Now here R by R, keep it as it is, R by capital R whole square is 25 by 49, or R by R is equal to square root of 25 by 49. So R by R equals 5 by 7. So this is 5 is to 7. So radius is R is to R, that is 5 is to 7. Clear? This is what the surface area of two hemisphere. Therefore, ratio of their radii is 5 is to 7. Ratio of the radii are 5 is to 7. Clear? Now, second problem. If surface area of a sphere, surface area of a sphere is 676 pi square centimeter. 676 pi square centimeter. Find its radii. Find its radius. Find its radius. See, here is a problem. If surface area of a sphere is 676 pi square centimeter. Look at this, 676 pi square centimeter. Now, we should find out the radius. So, just write down the formula. Solution. Solution. 4 pi r square is equal to 676 pi. Write down this like this. So formula first and then what they given. Then r square equals 676 pi whole divided by 4 pi. So cancel this. Pi get cancelled. 4 ones are 4. 4 ones are 4. 2 carry 27. 4 6 are 24. 3 carry. 4 9s are 36. So r square is equal to 169. R is equal to square root of 169. So r is equal to 13 centimeter. R is equal to 13 centimeter. This is the radius of the sphere. Now, let us take one more problem. If the total surface area, third one, if TSA, total surface area of sphere is 98.56 square centimeter. 98.56 square centimeter. Find the radius. Find the radius. Find the radius of the sphere. Find the radius of the sphere. So, solution. So, this is similar to the previous one. They are given the area. Total surface area is given. So, we can write this as 4 pi r square is equal to 98.56. Now, we want r square. So, r square is equal to 98.56 by 4 pi. 98.56 by 4 pi. Here, remember always pi is equal to 22 by 7 or 3.14. 3.14. So, r square is equal to 98.56 divided by 4. Here this 22 by 7, I am reciprocal this 7 by 22. 7 by 22. Okay. Now, here remove the decimal point. So it becomes what? 9856 into 7 whole divided by 400 into 22. 400 into 22. Now, 4 table. 4 2s are 8. 1 carry. 4 3s are 4 4s are 16. 2 carry. 4 6 are 24. 1 carry. 4 4s are 16. Okay. Now, again, here is a 100. Again, 4 25s are 100. 4 6 are 24. 4 1s are 4. And 2 carry. 4 6 are 24. Now, Next is what? 22 is there, 7 is there. Okay, simplifying, on simplifying you will get a 7.84. So 7.84. See, and simplifying this you will get 7.84, that is a r square. So when you take the square root, r is equal to square root of 7.84, then it is a 28. That means 2.8 centimeter. So here the thing is a calculation. How fast you are calculating the decimal part, then you will get the answer very quickly, right? So practice this once again at home and repeat the same. Now I am showing one volume problem. The volume of a cube is the volume of a cube, volume of a sphere. Oh, we should find out the volume of a sphere. Just showing one. The volume of a find the volume of a sphere whose radius is 2 centimeter. Whose radius is 2 centimeter. Now solution. R is equal to 2, y is equal to 22 by 7. Now formula 4 by 3 pi r cube volume. Then V is equal to 4 by 3 into 22 by 7 into 2 cube. Followed. See what they given? Only the radius is given and this value is a constant one. So you should write down as a 22 by 7. Write the formula. Substitute the value of pi and r. 22 by 7 into 2 cube. Then V is equal to 4 by 3 into 22 by 7 into 8. Now V is equal to 32 into 22. I multiply this and 7 3 is a 21. So V is equal to 2 2 is a 4, 22 2 is a 44, 4 carry 66, 70 by 21 cubic centimeter. If you want, you can divide 704 by 21. Keep it in a decimal part. Clear? This is a volume of a sphere when its radius is given. So, thing is remembering of the formulas. Okay. Now, another one. 1, the volume of a sphere, is 616 cubic centimeter. Then what is the radius? What is the radius of the sphere? What is the radius of the sphere? Here in this, they only given the volume. Then we should find out the radius. So solution. So 4 by 3 pi r cube is equal to volume. Then we want r, so keep this r cube is equal to v is, or another v by p into 3 by 4 pi. Okay, r cube is equal to 616 into 3 into 7 by 4 into 22. See here, this 7 by 22 is a 22 by 7 reciprocal. Then simplify this. 4 ones are 4, 4 ones are 4, 2, 4 5s are 20, 1, 4 4s are 16. Okay, now 11 2s are 22, 11 ones are 11, 4 carry, 11 4s are 44, 2 ones are 2 7s are. Okay, now r cube equals 7 3s are 21, 21 into 7, 21 into 7. So r cube is equal to 7 1s are 7, 7 2s are 14. So r is equal to cube root of 147. There is no cube root for this. So centimeter. I should keep it as it is. Clear? So this is a volume of the sphere, and hemisphere is also there. You are dividing that by 2. Whatever the volume you are getting, you just divide it by 2. That is the volume of a hemisphere.